So the final temperature better be close to 298 because you're only putting in a little piece of warm aluminum in there. And so the temperature rise isn't going to be very much. So that will help you ballpark it, right? If you do all this math, if you spend a few minutes trying to get the math right, and then you get an answer of 600 K, you're wrong. So you go back, you erase it all, you try it again. So oftentimes, remember, you have to do a problem 2 or 3 times to get it right and to understand it. So you can't just do a problem once and say, oh, I didn't get it right, I'm going to move on. Remember to do it over again until you get something. You know, whether you get 308 or 306, I don't know. I mean, maybe it was rounding, maybe something like that. I wouldn't worry about that stuff, but you'll be right in the ballpark if that's the answer. If you put 600K, I'll say, is that a reasonable answer? And you're not going to get as much credit as someone who puts 308K when the real answer was 306. They'll just say, ah, that was a rounding error, you're probably fine. Okay. Is everyone good on these heat transfer problems? Yeah. Study these. Make sure you know the process. Make sure you know how to set this up. But anytime we have some temperature change or anytime we have some heat flow, if we don't have a phase change or a chemical reaction, Q is m Cp delta T. Yes?
Will there be problems where we'll have to work out the energy gained by a phase change? Let's say that we like put in a really hot chunk of aluminum that caused the water to boil or something.
Yeah. So that's a good question because I gave you. So what if this was 50 grams of aluminum and it was at 900 C? So first, when you drop this piece of aluminum into the water, what's the first thing that's going to happen, thermodynamically speaking? What has to happen before it boils? It's going to heat up. This whole thing's going to heat up to 373. Then it's going to vaporize. So I gave you a question like that on the homework, or in the examples. It's more difficult and lengthy to solve, so I probably won't test you exactly on that. But you should know how to do it. So it's a two-part. This thing needs to warm up first. So you have Q of the warm plus Q of the phase change is the Q that's lost by this thing. So you can look at those that example in the notes. But I probably won't have a warming and a phase change on the exam. It's getting complicated for a 1 hour and 15-minute exam. Other questions? Go ahead.
There was one example you did in class. I think it's homework number 3. When you find the x's, when you do the q, how do you know which one you want
Yep.
to be x?
Yep. So this is a dissociation problem. So I know what I want for x. So say we take CH3, COOH. This is a weak acid, so it's going to go to CH3, COO minus plus H plus. So if I give you the pH, what do you know? If I give you the pH, you know the concentration of that thing, right? What's the reaction quotient for this reaction? Great. Okay, so if I give you the pH, it gives you a piece of the reaction quotient. That's fine. Maybe I give you KEQ as well. So usually what I'll say is at first I make a 1 molar solution of acetic acid and I let it dissociate. But I didn't tell you how much it dissociates, and so that's why we call this X and X, or 2X and 1X depending on the stoichiometric coefficients. And so the number you put here is whatever I give you. Maybe I give you the proton concentration, and so this would be 6 times 10 to the minus 5 or something like that. So you have to figure out, okay, based on what I tell you in the problem, what number do you know, And then what variables do you have to figure out from there? So oftentimes in straightforward cases, I'll say, okay, it's 1 molar acetic acid, and it's going to go to this acetate plus the proton. And so I'll often give you KEQ. And so you can plug in 1 molar here, or 1 molar minus X, but we know that X is going to be very small, so we can just say that that's 1 molar, this is X, and this is X. And so we can solve for X given KEQ.
Now, is that always the case? You can just disregard the 1 mole minus X?
Yeah, so if it's a weak acid, yes, or a weak base. So if the KEQ is low, low KEQ tells you that X is small. For a high KEQ, so what if the KEQ is 1 times 10 to the 5th? What do I know about this reaction if KEQ is 1 times 10 to the 5? The products are favored, and there's no reactant anymore. At 1 times 10 to the minus, at 10 to the minus 5 for KEQ, this goes to 0, and so I just have X squared equals KEQ. So it really depends on the magnitude of KEQ. Can I disregard this or not? If I have a high KEQ, X is large, and so then I just don't have any more reactants anymore, and so this, well, this won't go to 0, it will go to some small number.
So
Yeah.
low KEQ means that the reactants are favored, correct?
Correct. Low KEQ tells you that this side of the equation is favored.
Okay.
High KEQ, that side.
So if it was low KEQ, you said that would just pretty much go to 1, since it would be 1 minus X, and X would be a small number.
That's correct, yeah. So we could just simplify this as 1 mole. And that's so in the acid dissociation calculation PowerPoint slide that I put up in Angel, that assumption's made, and we did that assumption in class for pyridine as well. So you get to practice that on the exam. And instead of a weak acid like acetic acid, pyridine is a weak base. So it's the same calculation, same idea. Other questions?
So then, if the reactants are favored, then it's a favorable reaction, then delta G would be negative?
Yeah. So if the reactants are favored, is the KEQ high or low?
It's low.
Oh, sorry. Yeah. So so if the products are favored, is the KEQ high or low?
KEQ is high.
High, right? And if this equation, delta G0, is negative RT ln KEQ, if this is a big number,
Then it's gonna. Okay.
it's going to make this very negative, right? And that means that the products are favored.
Okay. Cool.
So it all fits together between KEQ, delta G0, positive, negative, greater than 1, etc. So when you get a problem on the exam or a problem on the homework, sometimes you have to write down a couple of equations and say, okay, what do I know? What do I don't know? What am I trying to figure out? What's given? You know, sometimes it takes a little reasoning to figure out what your approach is. And so that's not plug and chug. Once you know what to do, then you plug everything in and you can get the right number. But it's not, if I gave you the equation and I said the equilibrium constant is this, calculate delta G0, there's no skill in that. But the skill in solving these problems is trying to figure out what your approach is, what you know, what I'm really asking for in the question. And so that's why we only have a few simple equations, but you need to know how to use them. And oftentimes it takes starting the problem once or twice, 3 times to get it done. Yeah?
For the sheet, you only want equations on there? Like
You put whatever you want on the sheet.
So I could put low KEQ, X is small, I could put that.
You put whatever you want. You can put an example problem on there if you want. Yeah.
No, I copied the homework from my lesson.
You could write down all the homework problems on your sheet and bring that into the exam, but you can't photocopy the homework down to really small, right? The sheet needs to be handwritten. Yeah. You put whatever you want on there. poems, relaxation, mantras, doesn't matter. Yeah,
I have a question about the homework.
sure.
For the homework number 7, number 2, it says, what's the equilibrium constant, and it gives the enthalpy information of all of the with the reactions and products and the entropy.
Yep.
Do you, like what I did is I was just going to find the entropy of the reaction, the enthalpy of the reaction, and use the G equals H minus TS. But
Yep.
there's no temperature given, so I don't know.
Oh, so in that case, just assume a temperature. Say, I assume this is going to happen at 298, right? Because those are zeros, so that's usually under a reference state. So just say, I assume 273, or I assume 298, or I assume 300, whatever you want, and then solve it. Yeah, so that's exactly the right approach. And if this happens on the exam, if I don't give you a number that you need, just say, I assume X. Maybe it's a good assumption, maybe it's a bad assumption, but at least it allows you to finish the problem.
Right, okay.
So just like in life, right? Sometimes you don't have all the information. You're going to need to make an assumption to try and solve whatever problem you're solving. But yeah, on that one, I think I just forgot to put a temperature. Just assume a temperature, it'll be fine.
Gotcha.
Yeah?
Same homework number 1, part 2 is asking if the entropy of the universe is increasing, decreasing, or staying the same. It can never decrease.
That's correct.
And
Entropy of the universe less than 0 is not allowed.
And
Yeah.
if it would only be constant if it's a phase change, or if you're like dealing with phase change.
Only phase change, delta S of the universe is 0. Yeah. Other questions? We've covered everything that I want to cover for the most part. Calorimetry, delta G, equilibrium, reaction quotient, all that stuff. I mean, we're only covering 3 homeworks, right? 5, 6, and 7. And if you know how to do those homeworks and you understand them, not just, I can write all the numbers down, yeah, that's okay. And you understand the examples from class, you'll do fine. But don't get flustered. You know, remember, stay with